Welcome to the SARA Radio Telescope Observation Party for October 2024. And a couple of inputs. I got a new software package that allows me to edit the software and to dub it in different languages. And it has actually AI, so it'll actually make it look like the the mouth is moving correctly for different languages and things like that. And it'll allow captions and various other things. The other thing it'll allow me to do is edit for ums and ums. It'll actually take those out of the video so I can see the entire transcript, and it'll actually take out some of that stuff. So it looks like we have perfect speech. So it's going to be wonderful. And so there's all sorts of fun things that this thing will do. It's a lot of AI generated stuff. I can actually train the AI voice so that I can type, and then it'll actually, in my voice, speak like I'm speaking. So I can we just have video and no voice. I can actually just type what I want to say, and it'll actually use my voice and do a voiceover on video. So there's all sorts of fun things that I'm going to start playing with here on the rest of these videos. It'll also let me to cut and paste small sections. It'll actually recommend small sections so we can do short videos. I think you saw that when I was experimenting with some of the Radio Astronomy Australia videos. And then I can convert those to different languages. I did attempt to do a German language and a Spanish language. And they both appear to be very good translations. And they dub over on them. It actually looks like they're speaking. And so the one thing I didn't do is try to convert some of Wolfgang's back into German. I thought that was doubly redundant. He put it in English and I go in German. It wouldn't make sense. So I did his in Spanish, and it was a big hit. There's a lot of Spanish speaking amateur radio astronomers in the world, and which I didn't know. We're getting a brand new audience. Anyway, let's see. Mike, I'll show your pictures. Did you want to go over what you just did? Let me see if I can bring your pictures up.
I'll unmute myself. Yeah. So I'm very much of a newbie. I just started into this 5-6 months ago, and I've done a few projects. A few of the typical beginner kind of projects, one of them being the itty bitty and then meteors. So what I did here, I really wanted to do the scope in the box and the hydrogen line. And last night, Lester and I have been working through some possible issues with some of the software and maybe some of the dongles. Did you get my discussion with him, Rich, that the dongle works again? And also that the software, it might have been my computer, I guess is the bottom line, because I deleted a bunch of everything and then put onto my computer what Lester had sent me, and then plugged all the dongle back in, including the old one, and it worked. The bias T came on. That was good. And I'm just running a few tests for him now just to make sure things are good. But so after working through a couple little things, may have been on my end, this is my scope in the box. It's mounted on an Explore Scientific 2 Twilight mount. And so this was last night, pointed at the zenith. And then go ahead with the second picture if you have it. And okay, so you can see that's the stellarium on the left. I'm pointed right at the Milky Way at the zenith. And you can see that I have that line. Can you see my...
I probably can't see your cursor on that.
Okay, but you can see, can you highlight that? Or just show, yeah, it's obvious in the middle screen. That's your hydrogen line. It's actually between 1420.00 and 1420.50. And I don't know, this is my first time doing this, but that appears to be the hydrogen 21 centimeter line I think. Wouldn't you agree, Rich? That's what Lester thought it was.
1424.05.7 is your non-Doppler frequency for hydrogen.
And that looks like I'm right on top of it, doesn't it?
Yeah. Then you'll have a shift in left or right based on where the Earth is and compared to where you're looking at. So there's a correction to that, but from a raw Doppler, you're really close.
Yeah. And I sent it to Lester this morning, and he said, yeah, that's the classic double hump. And you can see to the right of it, there's a little rise there. Again, I'm new at this. So what is that one? The main hump is right at 4085 or 485 or whatever it is, the hydrogen line. But what is that just to the right of it? Did anybody? There's a little hump there.
I see 3 bumps, 2 little ones, and there's just more clouds of hydrogen out there moving at different speeds along our line of sight of view. This is all great.
Okay. So again, I'm new at it, but the big one is where most of it's at, but then it's Doppler shifted the 2 little bumps to the right of it.
Correct. Somehow they're moving towards us or away from us. And so in each direction of the sky, we get these spectrum of frequencies. You convert into velocities, and then all kinds of other study can occur.
Yeah.
The adventure has just begun. This is great.
Yeah. That's what I was thinking, because I've listened to the first time I came in, or I've listened to a lot of the videos by Wolfgang and so forth, and I'm learning. And the first few times I felt like I was the dumbest person in the room, which is actually an advantage because it's all good. It's all uphill from there. But I was pretty happy to at least detect it. And now I need to flesh that out with all the things that can be done with it. So yeah, I guess it was a fun time.
I guess it means the hook is firmly fixed.
Yeah, I think it's firmly fixed. Yeah, I would say. No doubt. So I'm going to have to study some more videos to see what can be done with it next in terms of what that all means. But yeah, it was good to at least set it up and do it. And there it was. So yeah, it was fun. And so it's a lot more to be done with this than say the itty bitty, which is where I started, and meteor detection, which is cool. So we'll see. Yeah, see where we go. That's my story, and I'm sticking to it. So
enjoy the adventure. I have a bunch of videos up there talking about through this whole process, if that helps you too.
Yeah, sure. I think SARA has got some phenomenal stuff up on YouTube, and I've been studying it and reading some articles. But yeah, the hook is set. So we'll see what happens from here.
Okay. Any questions for Mike?
Just a thought. I think Andrew here, I think the big hump will be the Sagittarius arm, and one of the other 2 is going to be the Perseus arm, I think.
And why is that?
Because those are the ones that are there in that direction. You first of all hit the Sagittarius arm initially, and then once you've gone through that, you hit the Perseus arm. Although I'm happy for anybody to correct me if I've got that wrong.
And they're moving in different directions relative to us.
Oh, okay. Okay.
Yeah, if I remember what Ted's told me before, this is slightly strange because you would expect them both to be Doppler shifted in the same direction relative to the Earth. But if you look at a top-down projection of where the Earth is relative to the Milky Way center and the arms, in fact, I could probably show you that if you were to unshare, I could probably share and show you that.
Yeah, I'd like to see that. No, I'm just one of 20 some people here, but it would be nice to learn just a little bit and then of course move on. I don't want to.
So here we are. So on this picture here, if you can see it, does it come up?
Yeah. Can you move it up a little bit? Can you drag it up a little bit?
I might be able to. Again, I'm happy for anybody to correct me in my labeling if I've got my labeling wrong there. Especially Ted, if you correct me, if relative to where the Earth is,
and where is the Earth? Is the Earth the green? Oh
no, the yellow spot, or the Earth or the Sun. That's effectively the same thing.
Oh, I see. Okay. Oh, okay.
At this scale, there's no essential difference between the two. And the green
Right.
spot is the center of the Milky Way. And in this
Right.
section, we're looking like a CT scan. We're looking from the top down.
Yes. Okay. Sure.
And you can see that what your hydrogen allows you to see is to see an arm. And unlike a normal astrophoto, you can actually see behind that arm to see what's behind it. And you can see there that there's the Perseus arm coming out behind that as well.
Yeah.
But what you need to do is take a line from the sun / Earth and go towards these this material, and you can see that you get some sort of strange sort of Doppler shifts because it's not, as it were, from the center of the Milky Way out. It's from the yellow dot out.
Yes. Okay. Yeah. So you're out on the frisbee. You're not in the center of the frisbee, or so to speak. And so, yeah.
Have I got that right, Ted, in terms of my explanation, or have I got it wrong?
I like it. Different velocities tell us where the different masses of hydrogen are, and we plot them using that velocity information with vectors coming out of the sun in all directions. So we're going from 0 to 90 degrees typically, from the top over to the left.
I've got another picture that might help you here a little bit.
Sure.
Where is it? Sorry. Blob. I forget where it is. Wrong direction, maybe. Here. So this is obviously not my data. This is professional data, and you can see there the way that you've got movement of material around the Milky Way, and the different colors there representing different velocities.
Okay. So which one is the Sagittarius arm?
What do you think, Ted? Or anybody else?
We have to go back to your other slide to remember which is which.
Okay. You don't have to do that. I get it. Yeah. You've got different things moving in different directions. And it seems like even towards the center there, there's purple and the dark blue almost overlapping each other.
Yeah.
And
then here's quite importantly, if you look at the red arrows there, right?
Yes.
Imagine you're out on one of those arms, no, not the center, one of those arms, and you draw a line towards the red arrows. Now, depending on which red arrow you hit, it could be going in one direction or the other direction.
Yeah.
So you might get a positive or a negative velocity shift because of
see that.
So it's a bit confusing.
Yeah, but you could see it. It makes sense because effectively I could be, or anybody could be, shooting across and getting one side of the inner circle going one direction and the other side of the inner circle going the other direction. Am I reading that correctly? If you look at the center blob and you've got red arrows going different directions, right?
Yeah, that's what I'm saying. Although there is a limitation to what you can get because of a limitation of the hardware that we're using and which bits of the Milky Way it's able to actually look at.
Yes.
There are other people in this group who could give a far better idea of what sort of potential variations you might see.
Yeah. It's a lot of stuff going on up there. One thing I do want to learn how to do, and maybe I can talk to you, Rich. Again, I don't want to dominate it here, but I'm trying to figure out how you figure out the beam width of the scope in the box. Is there a formula for that? Afterwards, Rich, could you send me like a link or something? Or I just want to try to figure that out. Or if it's already known, the beam width, cool.
Radio astronomy formulas, YouTube videos.
Okay, I looked through those, but I'm not sure which one. So anyway,
I have to go figure out which one too. But there's an easy formula for it. I don't know if any of you guys remember what it is. It's got to be pretty big.
You have to keep in mind that the scope in the box is a section of the parabolic. So its beam width is not necessarily going to correspond to what the true parabolic is.
But it's pretty big. It's greater than 10 degrees or 15 degrees, I think. And
if you're careful with your LNA, attempting to take the pattern off the sun and then convolving the sun's diameter with your result should give you a rough idea. I haven't done it, but others have. It's a pretty lousy antenna, which is why I'll bring up the subject that I just received my solar cooker. I haven't unboxed it yet, but I've got to make a feed for it. And then I'll have 2 antennas to play with.
Is that Lester Veenstra?
Yes, I am guilty, sir.
Okay, so did you get those other things I sent you this morning?
Yes, and it confirms my worst suspicion.
The bias T thing, right?
That my toys do not work in every environment, although they should. I've sent you a note saying why they should work, but I have no explanation. But you have proven what I was afraid of, that in some environment of the truly software impaired neighborhood, my tools don't work standalone. So that's got to be fixed.
Thanks for all I can say is thanks for all your help. You worked me through it. But yeah, if I sent you that stuff this morning and that covers what you wanted on the bias T thing, right? Oh, you're muted. You're muted.
I'm sorry. It tells me exactly my worst fear.
Okay. Sorry about that.
Why the customer that my tools do not work on. That's not your fault.
Yeah.
That's the tool's fault. Well, that's got to be fixed.
Okay. Glad you got that information, but thank you again for your help in getting me to the point where it works for me. Yeah.
Oh, by the way, it's lesson 2, Smith. Yeah. Lesson 2.
Okay.
Astronomy formulas. Half power beamwidth formula.
Okay.
Yeah, I put those together for this very reason, is that I had to go, when I first started this, I had to go figure out what all these formulas were. And if you go through those things, it'll give you a quick idea how to calculate them with some examples. But you'll find that I think Ted, I don't know, do you remember what for the scope in the box, that little, it's a very huge beam width, which in other words, you're seeing a big part of the sky when it's going by you. So it's a big fuzzy image of what you're seeing. It's not precise,
right?
The bearing you're looking at. But for our purposes, you're seeing a very good signal there. With the
what we'd like to do is point the antenna at some transmitter and then move that transmitter back and forth in front of the antenna and look at its response. The easiest way to do that is point it up to where the sun's going to be, let the sun transmit, let the earth rotate, and the sun travels across the sky as far as we're concerned. And the transmitter is moving in front of the antenna, and we will look at the response. And then there's some half power beam width we can look up in Wikipedia and learn how to calculate that, a nice measurement to describe that antenna pattern.
The only issue with that is you've got to convolve the diameter of the sun. So that's probably not much.
Which is about half a degree. Yeah. So subtracting that gives a good chance. And I think what you'll find is it's about 30 degrees of a beam width, which is a big part of the sky. What you need is a good 30, 40 foot antenna now.
The other thing I found out as a novice radio astronomer is that I had very poor pointing capability, and that beam width really saves you. Even though you're not as precise, you're not exactly pointing where you think you're pointing, but you're still getting a signal in the range you're looking at, just because you got this big beam width. As soon as you get your pointing accuracy down a lot better, then you can get a bigger antenna, and your beam width comes way down. We had this problem with the 18-meter dish down in Haswell. We were trying to find pulsars, and we figured out the beam width was 0.8 degrees, and we were missing the pulsar because we couldn't point precisely. You got just the opposite with that little dish, but you're going to see the whole sky. Just don't count on the fact that you're pointing in the exact degree you think you're at.
Yeah, good. Okay, that's really helpful. So that is just the scope in the box is just part of a larger parabolic dish, right? Is that it's just a section? Is that what it is?
That is absolutely correct.
And do you know how big that parabolic section or parabolic mirror is if we did the whole thing out?
You measure on the top and see what the distance
Okay. Yeah.
distances, and that's what you're gonna use.
Okay. So I'll just use that in the formula.
Yeah, it's just how far, and it's a little different with that dish because you don't have a full parabolic dish, but it works really close.
Okay. Oh, that's
you see
fine.
some of Alex's videos. You also see how he converted that thing into a full dish and improved considerably, because he started with the same thing you've got, but he improved it.
Oh, that's right. I've seen that. Yeah, he's got all that stuff out on the side. Yeah.
But that's still really taking a dish that wasn't meant to do radio astronomy and converting into a better dish using the same equipment that you've got in your scope in the box kit, the LNA and your receiver. You can still you can take all that and put it into a big dish and it'll still work.
Yeah. Yeah. Good.
So,
Okay. So in the formula,
you'll never end trying to get a bigger dish until you get the dealer. And I'm sure Wolfgang even wants a bigger dish. If someone handed it to him, he would take. It never ends. It's just like ham radio. You never have only one radio.
Yeah, I can see that. I'm just encouraged that you can take an off the shelf stuff and put it together and actually do something worthwhile. And for, like I said, a newbie like myself, who's only been into radio, counting on months, you can actually do that. I thought, what's a good system?
I think one of your next
on the hook.
Yeah, oh no, I'm on the hook. I get it.
Mike, I think one of your next, if you really want to get the pictures, start looking at Ted's software package. Yeah. You can take your data and you can come up with this stuff that you just saw Andrew show. That's what he did. And then you're really hooked, because then you're just going to improve your telescope side, because all of the processing's done. Now it's just a question of how to improve the telescope, make it bigger, better, more sensitive, pointing better, things like that. And then you'll see that picture improve.
Yeah. Yeah. So yeah, the hook is set.
Okay. No problem.
No, I'm just thinking of time and money and space in the backyard.
You don't have enough time and you don't have enough money.
Right.
And your wife won't let you have the space. It's all that's the variables.
Oh yeah.
Okay. I'll let you go. Andrew, why don't we go with you?
All right. Okay. Thanks. Yeah. Just a couple of bits of advice there for him before we move on. The question of how big the dish is equivalent to. So these dishes, these Newbie dishes or equivalents, are roughly 100 by 60 centimeters. So you actually orientate them on the long axis, east to west, because you're doing drift scans.
Okay.
And to make sure that I remember it now, but there's the actual waveguide has to be at the right direction as well. And then you get the actual 100 centimeters or near enough 100 centimeters of effective resolution. So you've got basically a 1 meter dish as far as resolution is concerned. Obviously, it's a bit less in terms of radio wave collecting service. Newbie do produce one of these grid dishes that's actually tuned to 1.4 gigahertz. So if you want to actually get one that's actually tuned to the right frequency, then you can buy one. Having said that, what I'm going to present now is I actually got one of these solar cooker dishes after somebody put it on the mailing list. So I'm going to send my first light from this week.
Andrew, can I ask you a quick question? When you said 100 centimeters, is that the diameter of the scope in the box? Is that what you were saying?
With the Newbie 1.4 gigahertz dish is 100 centimeters by 60 centimeters. I'm not quite sure exactly what size yours is.
Oh, okay. Yeah,
because
no problem.
I'm not based in America, and outside the States, you can't order the scope in the box package to be delivered. So I know that Les is looking into it at the moment. So when I got it, it wasn't an option. So with his help, we sourced some local materials. It meant I had to work out which was the best dish, and Newbie could just produce this dish. But I wouldn't rush off to buy one of those if I were you. You're getting quite a good signal there, and you can do an awful lot with that. You can map the Milky Way, you can weigh the Milky Way, and you can demonstrate dark matter. And I would go ahead and do that with those before you do anything else.
Okay. Yeah. No, it's a good start. It's a good system. I'm impressed. Like I said, just off the shelf, doesn't cost a lot, and you can do pretty good stuff. So
yeah, one last little bit of advice, which is a practical bit from my experience. I also played around a lot getting bias T to work, and I also had difficulty with it working. And I also eventually got it working, which is great when it was working. But I've come across another problem with it, and that is that every time I turn the computer on and off for whatever reason, I forget to press the BIOS T icon to restart it. And so I've sat there at one point with a week's worth of data that was worthless because the software-defined radio had not been turned on. I've realized that actually, if you have the option to do so, externally powering your software-defined radio is worth doing if it has an external power socket. Some of them require a DC block to go between the radio, sorry, it's not the radio power, sorry, it's the, forgive me, it's the Newbie Sorbird that you've got to power, sorry, right, externally. And my understanding is, but again, somebody can correct me if I've got this wrong, but I read somewhere that you need to stick a DC block between the Newbie Sorbird and the SDR if you're going to externally power it. I don't know how true. I've done it. It definitely works like that. I have no idea how necessary that is to do it.
A warning on that, Andrew.
Sorry?
A warning on that.
Yes.
It's a USB socket that you power it. And whatever you don't power it from a USB plug-in, AC adapter, because those things generate a huge amount of noise. In other words, you could power through that USB socket, give the DC to the LNA.
Yep.
But don't get it from a USB power supply. Get it from a clean 5-volt power supply.
Okay, well, that's worth knowing. That's worth knowing. Did you think a DC block is required between the Newbie Sorbird and the SDR?
I don't know the answer to that. I'm going to find out because I've got a DC block in my hand right here. So I'll try it to see what happens. As for good practices, I would use the DC block. And if anybody needs one, I've got them. I just have to be able to ship them to you. So Andrew is the problem. Everybody else is not.
Okay. Andrew, it really depends on the SDR, whether you need a DC block. All SDRs that have a transformer at the input will require a DC block, because otherwise you'll either short circuit the DC voltage from the power supply and even damage your SDR. So the good practice would be, as Lester just said, use a DC block if you're doing external power to your Sorbird. Because the trouble is, if you feed it locally, the Sorbird, it feeds back the DC on the coax cable, and that can burn your SDR.
Oh, that's what I'd read, so that's quite correct. Thank you, Wolfgang. Yeah, so I'm glad job I did it then. Good job I did it. Okay, anyway, for me, was to present it was put on the SARA list. It's the solar cooker dishes that were on eBay USA for $50. These are 1.5 meter dishes, and they seem like a very cheap way of creating a radio dish, and a number of people sort of waxed lyrical about it. Now, these aren't sold on the eBay UK site, at least not directly from the UK. You can buy them in America and have to pay about $80 postage to get it over. Then you go hit for tax on the way in. But when I looked on eBay UK, lo and behold, I found somebody who was doing a house clearance here in England and actually had a couple of them to get rid of. So I picked one up for £50, and I now own a solar dish, which I thought I would just show you this week. Managed to get a bit of data eventually. I will show that to you if you don't mind.
And we want to know what you use for a feed.
Use for what, sorry?
Which of the many suggestions did you actually wind up using as a feed?
Oh, at the moment, you'll see. You can have a good laugh. It's just to get something started. So can you see that slide that says my latest acquisition, 150 centimeter solar cooker dish?
Looks good.
Oh, good.
Good. Yeah. That's just to give you an idea of the size of this thing. There's SETI in our extension completely covered by some of these petals. And then it's put together there. I did this, of course, when my wife was out for the day and didn't realize what I was doing. Together, the raining outside. And then here it is outside. It answers your question. At the moment, all I've done is just shoved my antenna into the hole that's meant to actually hold a saucepan or a kettle. And you can see that's had some paint on it to try and get rid of its very bright surface. The reason for that is put it together, even though we don't get much sunlight around here and it's autumn, holding a cardboard box at the right position in front of it led to an awful lot of smoke coming out in a great big hole in the cardboard box. So I didn't think it was particularly safe. So I found a bit of cheap paint and shoved it on. So that's clearly not an ideal position for this antenna. It's roughly at focal point. It's also at a wrong angle and everything, but still something to give an idea and see how it worked. And so here we are. So it's a couple of data points this week, or at least a couple of elevations. Easy radio astronomy there. Ted, feel free to comment. I'm guessing the double peak we've obviously got two peaks on the side, which are going through the Milky Way. The bottom line seems to not have the double peak of the top line, so I'm guessing that's the sun. The double peak possibly if it's hitting a tree, which might be well there in that direction. Since splitting the sun up either side, I'm guessing, I'm not sure. And then there's the 191 plot on the right-hand side for data integrity. And just to show, apart from that even with these couple of elevation points, I can have a go at weighing the Milky Way. We're not too far off. We're only 15%, I think, is it? So about 20-25% over the actual measurement. There we are. So that's what I have so far.
Any measurements relative to the Yankee?
The Yankee I've been having a lot of problems with in that socket to work properly. Alex has been helping out with a lot of that, but I need to revisit that. I don't know what on earth's going on with that. My main one's still the tarmac, and it's busily working away in the corner, doing its mapping exercise. But I don't know why I'm having issues with Alex's Yagi.
Well, a solar cooker can beat the military.
Yeah, I don't know. I think I probably need a good feed, and I'm not sure how well the antenna will perform.
Well, you probably have some pointing issues with that feed and that angle, but it looks like good promising.
Yeah, but that was just for testing purposes. I still have to construct some mechanism for holding that antenna in the right position.
All right. Okay, let's go to Peter East, also in England. I'm sorry, UK? The UK or England? What do we say?
We're back in England, but we're also in the UK. England's part of the UK. Okay, as Rich, I've been putting together a paper on getting a good estimate of ground noise and spillover noise on dishes. And it's nearly finished, and I'll be submitting it soon for the journal. The reason I started it is basically work I did about 10 years ago for a UK university. They wanted this sort of information on some antennas that they built. And a little while ago, there was in the forum, somebody brought up John Krause's estimate ground noise, where he split an antenna into three parts, a main beam, a side lobe and a back lobe, and came up with an estimate for it. But anyway, the method that I'm talking about, with the paper, there'll be a couple of Excel spreadsheets where you can put your own data in to find out about ground noise and spillover noise. But basically, to do the job properly, you completely measure the antenna, the azimuth elevation patterns, and then do integration over the relevant areas to work out what the response is in all sorts of directions. But I've come up with a much simpler algorithm to do that. It's a bit coarse, but it does give some good answers. The original problem was that with ground noise, it varies as you point the antenna. Normally we like targets on the zenith, and you can get an estimate of the ground noise in that direction. But once you tilt the antenna, then the ground noise changes. And now the particular application that I was looking at was very sensitive to ground noise, and they wanted to know what the ground noise input would be as you tilt the antenna from the horizon up to elevation and so on. And similarly with dishes. The interesting thing about dishes is that once again, as you point the antenna, things kind of change. And normally you design the feed. The general rule is for minus 10 dB side lobe, minus 10 dB edge illumination. And that's a pretty good one. But there are two parameters of dishes that radio astronomers are interested in. One is the F over D ratio, where you need to know the focal point of the dish so that you can put your feed phase center right at the focus. And the other thing is what actual beamwidth, how does it vary with the beamwidth? How does the spillover noise vary with beamwidth? And how does the F over D ratio vary? Basically, what I found with a couple of designs is that the optimum beamwidth or optimum feed for a dish's F over D ratio doesn't give you the best G over T, which is what we're interested in as radio astronomers. We want the best gain to noise temperature ratio for the whole system. So anyway, my program, my simple spreadsheet program, allows you to investigate both these areas: ground noise with tilt and spillover noise with F over D ratio, and what beam width you need, what beam shape you need to get the best G over T ratio. So you'll be seeing that in the journal.
Thanks, Peter. You guys got any questions? All right. And by the way, the journal October 12th is the journal deadline. And Mike, I wouldn't mind having those pictures in the journal. Maybe put some words and make it like a 2-pager and put some words behind it, and maybe how you set it up and how you observed it, where you pointed it. And that's about all you need. And put that in the journal, your first journal article. You're on mute, but
yeah, I'd be okay. So you have the pictures, right, that you need?
I do. I just go ahead and put a little 2-pager together and for an observation report. And that's all you need. Don't need much. It doesn't have to be very formal, and I'll tune it up when I get it.
Sure.
So
when do you need it?
October 12th is the deadline.
And just a description of the process. Yeah.
Yeah. Observation reports are very informal, and I'll tune them up if they need to be tuned up.
Yeah, no problem. Yeah. And is that an electronic journal?
Yep.
Okay.
You've gotten it, right? Didn't you get a copy of one?
Yeah, I think so. Mm-hmm.
Okay.
Yeah, I'll try to get it by the 12th. If not, is there one monthly? Is that the deal?
Every 2 months.
Every 2 months. Okay. I actually write for an archaeological magazine also, and I've got a deadline on that, Rich, that I have to meet here.
Not a problem.
I may have to do that first, and then so if it waits till December, I'll put it on my list to do.
Okay.
But I got to get that. I'm committed to that other one first. So
not a problem.
Okay.
And then thanks, Peter and Wolfgang.
Yeah, let's see what I can tell at the moment. One of the things that we do as a regular exercise is to do observations of a Magnetar. That's a Magnetar which has a characteristic that every now and then it goes into a phase where it emits a large number of single pulses. And we had one of those activity phases just recently. These activity phases, sometimes they're a month, sometimes they're just a few days. And this time we had maybe about a week or so of a high activity phase. The interesting thing is that we had a concurrent observation on the most active day by the Torun radio telescope. This is in Poland. It's a 32-meter dish. And the observations just happened to be pretty much the same time. And we are now analyzing the data from both observatories to see, okay, how do the pulses that they see and our match? What I should mention, though, is the Torun Observatory, they observed in C-band, so that's a 4-point-something gigahertz. So they're in a different frequency band. And that's really the interesting part of it, to see how broadband are the pulses. Are they concurrent? Are they not concurrent? When we observe it, we have something like, on that day, we had 266 pulses during the observation time. The Torun guys had an excess of 100 pulses, and now we're in the analysis of the data. I don't have any results yet. But the motivation behind that is, again, the question, are fast radio bursts, are they magnetars? And they have a certain spectral behavior, the FRBs, and we want to figure out whether we have a somewhat similar spectral behavior from the magnetar. If that's the case, it would support the theory of magnetars being the progenitor of FRB. So that's pretty much what I'm working on right now. Other than that, we do have a KU band interferometer, which has been dormant for quite some time. So we are, reworking that at the moment, having some issues with that, but I'm hoping that we get that online in maybe 2 or 3 weeks. Then we can start observing in KU band again with an interferometer. And I guess that's all I have for the moment.
Thanks. And let me ask I did do that translation. I got about 50 hits on it for the German side. And I was wondering, is that useful? Do you guys want me to do more of those translations? Or you got a community over there that'll actually pick that up?
First of all, let me say this was an excellent translation. I was really amazed by it because the vocabulary was spot on with very few exceptions. The grammar was correct. The artificial voice that talked had a very good pronunciation with just a little, very slight American accent, but almost negligible. It was really fun listening to that German translation. And this morning, I think it was this morning, my wife notified that I'm now starting to speak Spanish. I hadn't noticed that, but my wife told me. So I'm pretty sure that's almost or as good as the German. That should be fun. As far as translating things from the YouTube into German, the German community, the majority of people there speak English, but there are always some people for whom it is more difficult to listen to English. So I would say it's probably worthwhile. And maybe if you can do a few things of the presentations and see how many hits do you get. And if that is a certain number of hits, that could be a motivation to do more. But once again, that's really a great job, both of you and the artificial intelligence behind it. Really great.
Yeah, and I'm saying you're very popular in Spanish-speaking people. I didn't realize we had it, and we'll keep that up. And by the way, it does use about every other language. I think I only have I think I can't do 10 languages because I think there's a limit on how many it'll allow me to do before I start running into it's past my subscription number or whatever. Yeah. But if any of you guys have a community that you think I should translate some of these videos into, let me know. I would love to try it. We have a big India based group, and that's Hindi. It doesn't translate it verbally into Hindi, but it'll do the captions in Hindi, because that's where a lot of our grants go to for stuff is India. A lot of schools over there have our radio scope in the boxes and things like that the grant committee has sent them. So I tried that, and it didn't allow me to do Hindi and verbally, but let me do other things. And so let me get to, speaking of that, now we got Dimitri, and it will be Russian, I believe.
May I just make one more comment on what you just said? As far as India is concerned, while Hindi is spoken in large parts of the country, I had the experience with the students that come for lab courses to our place from India. There are quite a few. And they tell me they have to talk to each other in English because they speak their local languages and they can't understand each other. They say sometimes we can work with Hindi, but we prefer to do it in English. The other comment, as far as other languages is concerned, would be French. I'm not sure that there is a French community in radio astronomy, and I get the impression that they're isolated by themselves because of the language. Typically, French people are hesitant and do not speak that English. So it may be worthwhile also giving that a try if your subscription allows that, to maybe try it and see how many hits you get in French. Okay, now I shut up.
Well, tell your wife you're going to be speaking French in the next couple of days and see how she likes it. Okay. Dmitry, I'm pretty sure it'll do Russian. I didn't know if you think I should do a Russian version of maybe one of yours. Go ahead, Dmitry.
Hello, hello to all. I'm not sure about Russian version. Not too many interesting radio astronomy. I just know two people working including in hydrogen, galactic hydrogen observations in August, eager get membership in SARA. I think they will take, they will be active online, great launch, and maybe one testing translation can be done, but I'm not sure because of not too many people with radio astronomy. As a matter. I last time in September, very close. There was a problem from my side. Internet connection and presentation. I will repeat the presentation.
Go ahead. I'm starting to see your screen.
Do you hear me well? No, not some.
Okay, the screen looks good.
Yeah, we hear.
Okay. This is about detection, laser explain 7 gigahertz line observation were made in September. So shortly about this. This were very strong line from this laser 6.7 gigahertz stable laser. This is the data up to March 24 from Japanese base. I met my line about 4 or 5,000 Yansky. This is tactical spectrum. Japanese tactical spectrum for this laser. This laser is located in southern hemisphere. In Moscow, with maximum elevation 15 degrees, not too high over the horizon. This is the strongest made galaxy. Major is top bright 6.7 gigahertz laser. This laser of type 2 pumped by infrared radiation. Several pictures from database laser DB net. This is short infrared picture, some spot, but best view of infrared spot is long wave infrared to infrared. It can be, it's maybe even sub-millimeter terahertz band, and even millimeter wave bands. Very, very good infrared spot. And very, this frequency variance better for measurable applications and pumping with my instrumentation. Here 2.4 meter width, designed 4 millimeter wave gap, system equivalent flux density about 1 Yansky. For my minimal detectable flux density about 100 Yansky for 1 hour of integration for my observation. This is the result observation. Very, very strong line in my observation to 5 Yansky. Levels are possible and underestimated comparing with Japanese data integration 1 hour. Observations were made in beginning of September. That's all for now. If some questions are.
Anybody have any questions for Dimitri? Good stuff.
Okay, sir.
No? Okay. Thank you. All right. Edward.
All right. So yeah, we're going from meters to more meters essentially, because I also have a whole bunch actually of major observations that I was able to do over the past 2 weeks. We have some pretty good weather. So I can share my screen, see.
There we see it.
Yeah. All right. Okay. So yeah, I've been doing some observations of water meters yet again. No news on the new mount that I've been working on, because that project has essentially stalled. I haven't really made any progress on the new mount for the 1 meter disc. Yeah, the whole onset thing is just too complicated. I just can't get it to work, no matter what I do. So seem to be getting stuck on the dead end there. But yeah, it's not really a problem, because I still have, of course, HEQ5, which I originally bought for astrophotography. Turns out my camera is broken. For the foreseeable future, I won't be doing any astrophotography anyway, so I can just use it for radio astronomy. Yeah, I re-observed some sources that I at 22.2 gigahertz that I haven't observed in a while, and also be continuing observation programs on some of the resources that I've been following for over 2 years right now. So let's just start with the Western 49. Yeah, this is a very massive star forming region, and it's also host probably the most powerful water mazes in the entire galaxy. This is a very strong source, so it's very often reaches densities of tens of thousands of Jansky. So even with the 1 meter disk, it's quite easily detectable, and I've been following this source for over 2 years at this point. So currently there's not a whole lot of activity going on here. On the left you can see my most recent spectrum from 16th of September. Pretty good signal to noise ratio. I was quite happy with that result. To the right you can see a compilation of all the spectra that I've collected over the past 2 years by now in this waterfall plot. So essentially the horizontal axis is the velocity, vertical axis is the time, and the colors representing intensity. So I do have to note that I still haven't figured out a way to do any sort of real calibration to flux density. At this point, it's still very much just looking at qualitative changes in the general profile spectrum, rather than any quantitative analysis of like how the brightness of the maze is changing. But yeah, still you can see that this thing is very variable. So especially in the
2022 and 2023, there were some quite strong flares, so some peaks in the spectrum of the maser became very strong. And yeah, over the past few months, there's fairly little change in the spectrum. This source seems to be relatively quiet right now. The West Route 51 is another very big, very massive star-forming region. It's actually quite close in the sky to West Route 49. So I haven't paid too much attention to this source over the past year. It's not very active in 2022. I've actually even written a report on it, and you can find it in the, I think it was the December 2023 SARA journal if you're interested. So yeah, right now it's at a fairly low level. It took me about 1.5 hours to get the detection of this source. So if you look at the website, you see my plot from last year. There's only one faint signal that was detected. It's about 57 kilometers per second, which is about what we expect for this source. And on the right-hand side, you see my most recent observation from the 20th of September. And there you can see that 50 and 65 kilometers per second there appears to peak. Yeah, the signal to noise ratio of 4, so it's a little bit difficult to interpret. It seems there is some activity in the way that some more peaks have popped up in the spectrum. It's hard to tell at this signal to noise ratio. So let's now 55. Yeah, I won't be discussing this in much detail, but I detected this source again recently, still quite easily detectable. G25.65 is 1.05. It's a whole mouthful, actually, just the coordinates of the source. So this was a tricky one to detect, actually. I had the source before last year, also took quite a lot. So this is also a very interesting source, also star-forming region, and it hosts a major source that is known for quite rapid and extreme flaring events. So the last one was in 2018, when it reached the density of 100,000 Jansky, which is very intense for what a major. Yeah, but currently, of course, at that time, I didn't yet have my 22 gigahertz set, so I missed that flare. Currently, it doesn't seem to be that strong because it's 53 hours to detect anything. But weirdly enough, when I observed this source in September, I saw actually 2 peaks. I didn't expect that. So I repeated the observation a week later, and I didn't really detect anything with certainty because the signal to noise ratio was too 4. Maybe there's something at 40 kilometers per second, but it definitely didn't detect it.
Hey, Edward?
Yeah?
Real quick, people are having a hard time hearing you. Can you get closer to the mic or try to get a little louder voice?
I'll do my best. I know. I always have this problem. I just have very bad microphones. My laptop is falling apart. That's the problem.
Okay, that's how, whatever you're doing right there, that sounds really good. You can stay at that, whatever you're doing, that your voice is loud now.
Okay, all right. I'll do my best. Continue. Why doesn't this work? All right. Finally, I also did some observations of West Route 3. Again, this source was, to my surprise, also quite tricky to detect because earlier it was quite strong and I could easily detect it. But now, yeah, I observed it 2 days ago, and yeah, initially I didn't detect anything after about 20 minutes. So I just decided to just leave the telescope running for the rest of the night for about 4 hours. And the next morning when I woke up, I just checked if I could detect if it detected anything. And there it was. So this is quite a complicated region. Here you can see an infrared picture from the WISE survey. And there's actually 2 different star-forming sites within this region, and they are only about 15 arc minutes apart. And well, the telescope beam is about 1 degree, so I can't really separate these 2. The resolution of the radio telescope is just too low. However, if you look into the literature, the water masers in those regions do have slightly different velocities. The northernmost region, W3 Iris-5, those water masers there tend to have somewhat lower velocities of around minus 40 kilometers per second. And the southern region, Lester 308, this tends to emit that the region seems to have a slightly more negative velocity, minus 48 kilometers per second. It's a bit more blue shifted. Yeah, if we then look at our plot and look at these velocities, then we can see that there's some overlap in the reported velocity range, so that complicates things a bit. But we can see that the two tentatively detected peaks at around minus 35 to minus 40 kilometers per second, they are pretty close to the average peak velocity for the W3 Iris-5 source, the northern source. Whereas the somewhat stronger peak at minus 48 kilometers per second is pretty much exactly spot on for W308. So when we look at the spectra that I collected over the past 1.5 years, we can see something interesting, and that is that initially the line that probably belongs to W308, it didn't really appear until about a year ago. So it was initially below the detection limit of the telescope. And when you look at other features that probably belong to W3 Iris-5, yeah, those seem to be getting weaker comparatively. So it's like W3 Iris-5 is slowly like fading out, and W3OH is slowly emerging from the noise, so to speak. So it's quite interesting to see like this slow sort of variability. So yeah, what could be going on here? I have no idea, but possibly a slow decrease in the pumping rate in the W3 Iris-5 region. But that could cause like a sort of slow decline in its intensity. Anyway, that's all I had to show for today. So are there any questions?
Great stuff. Great presentation. Do you have any questions?
Maybe just a short comment. You were referring to W3OH, and you weren't quite sure. I just checked against our data, and it's really spot on as far as the VLSR velocity is concerned. So I'm pretty certain that's the one.
Cool.
All right. And by the way, Edward, what is the native language where you're located, and what's the language, if I wanted to translate, I would use?
I'm in the Netherlands. We are a fairly small country. So I think there's only, maybe like a couple handfuls of people interested in radio astronomy. Like, we are a very small community.
Okay.
I guess I almost know them all, and they all speak excellent English.
Okay. Yeah. All right. I won't worry about the translation thing then. Okay.
And they also speak very excellent German.
Okay. All right. Okay. Thanks, Edward. Dennis.
Okay. I wanted to make sure that wasn't the other Dennis you were asking for. I don't know if he's even nothing really to add. I'm really enjoying all this information that I'm getting. Anyway, I'm about ready to put my scope in the box up on a mast next to my house and just fix it at the zenith where I'm in a scan mode. I've been thinking that it seems like we could tune the pickup at the focal point to closer match the hydrogen line out of that in the commercial Wi-Fi antenna. I would think that we could open that little antenna and dial it a little bit or something and increase it. Let's see, I guess we want to decrease it to 14 from 20 some for Wi-Fi, I think. Anyway, I'm thinking that would be fun to experiment with, to fine tune the antenna and get better activity out of it, more signal.
So Alex has done a little study on that. And of course, we're dropping frequencies, so the antenna has to get bigger. Talk to Alex about what he's done.
And the
Studies
antenna,
of different feeds.
you're just saying that you're talking about, for one thing, the larger the dish, the more refined your channel, your focus, more narrow focus with a larger antenna. And Alex was talking about, oh, there we go. I see. Les says he's got his little antenna dipole sticking up there, and maybe he can add to that.
Yeah, I doubt we're going to gain very much. I was looking at it with a VNA, and it is slightly high in frequency. But there's two pieces to this antenna. There's the dipole, and then there's the matching section down here. Oh, you've actually got to fiddle with both of them.
I see.
And in the end, I said, yeah, but this is such a crappy antenna to begin with. It's not worth the effort.
Okay.
I'd rather build some of the cantennas and the other ones that people have been talking about and try to improve this. And as I said before, I just got my solar cooker, so I'm behind the Brits, but I'm going to catch up.
Okay, just be careful you don't melt your antenna using that solar with all the IR you're going to get in there.
The first thing I'm going to do is put a wood rod directly up the central point, the central axis, and see if there's any difference of opinion based on how dark the wood gets as to what the focal point is.
That's a good idea. Thanks a lot. Thanks, Rich. That's it for here.
Okay, thanks. Bob Alexa.
Yeah, that was good pronunciation. Can you hear me?
I can.
Okay. So for my first project, I decided to go with a SuperSID, and I ordered it. I received it. I went to the Stanford website and decided to go with the 2 meter square that was done out of the PVC pipe. And now I'm just trying to figure out how I'm going to wind a wire around it, because I got double the antenna wire, so it give me at least 30 loops at the 2 meter square.
Yeah, my recommendation is put it on some kind of a wheel and then turn it. When I tried to do it, I tried to hand wind it. It just takes a long time to hand wind it.
Now I was thinking of inviting my neighbors over or something, and we each have a corner and then just wrap it around it.
Yeah. Yeah, that's going to be fun. Yeah, I had mine for about 5 years. It finally died, and so I'm going to have to get a new one. But yeah, it's one of the best radio telescopes I ever had.
So that's what I've been, instead of doing an H line first, I decided to do SuperSID.
Yeah, you'll have fun with it. Okay, thanks. And I did have a question. Is the reason I pronounce your name is because I yell at my TV and say, Alexa, go to this channel all the time. Do you have that problem that your Alexa picks up and every time your name's called?
Oh, we don't have one.
Oh, if you get one, you're going to have problems because it's the same pronunciation. Okay. All right, thanks. Let's see. Helen. You there, Helen? Okay, Bob.
Yes. No,
Oh,
I'm
I'm
here.
sorry.
I'm sorry. Yeah, I've been gone a month. As far as the languages go, I thought about that group that you had from the Philippines, if they might be interested in receiving that information in their own language. They speak English really well, but I have family there. In fact, they just got back here a week before you had that last program. And next time they go, I just send them over there to check out the place. But it was just a thought.
Wait, what language is that?
They would speak over there. They all speak Tagalog.
Oh, I have no idea if I can do Tagalog, but I'll look at it.
Oh, okay. That was just an idea. Okay, thank you.
Okay, Okay,
I've got a
thanks.
cold, so I'm going to go.
All right. I'll get
Okay.
better.
Thank you.
Let's see, Bob.
Yeah, nothing to report really. I duck out here for a while, so I'm gonna have to watch the recording because I'm sure there's a lot of good discussion that I missed here earlier. But I've been fighting problems with hard drives here on my Meteor camera collection system, and I'm analyzing the difference in mechanical rotational hard drives, solid state drives. Look like the actual mechanical drive should be more reliable. But I'm doing videos of 4 different cameras every night. So it's a bunch of data that's being crunched every day. That's turned out to be a big project this week for me. But other than that, nothing else to talk about really. Back to the gig.
Okay. Thanks, Bob. Let's see, Tom, our illustrious treasurer.
Good afternoon, everybody. I have nothing to report in the way of observations, but I will try to dig out a report, a presentation I did once upon a time that might explain how we name stuff. And the problem for radio astronomy is that we tried to be consistent with what the optical astronomers were using. And one of their problems is they cannot see the center of the Milky Way, and we can see through the center of the Milky Way. So that's on a different computer. So I'll do that. And up until about 5 minutes before the start time, I was doing renewals. So there's still a bunch of people who have sent in renewals and they have not yet been processed. I think I'm up to about the October here on the processing, but I'm working on it slowly, and I'll turn it back to the host.
All right. Thanks, Tom. Yeah, we haven't renewed for 2025. We are in our renewal process. We got 681 people on the list, and 50 have not renewed for 2025. We may end up dropping probably, I think we're going to get down to about 400 people because some of those renewals haven't happened since 2020. And so they're probably not really there. It's like voter rules. Eventually you got to clear them out and then start with the active members again. Anyway, but we are doing good. People renewing very quickly that are there. Okay. Les, did you have anything else?
As soon as I find where I am here. No, just that I've got my solar cooker, and that'll be the next thing I'll get to eventually in the next few years.
Okay, Ted, last but not least.
Thank you. Let me turn on the audio first. Hello. With great hope, I tried to put up these 3 antennas on a fence at the Little Thompson Observatory. I'm hoping you're seeing that. And I spread them out for an interferometer, and I was greatly hopeful, but I think all I'm doing is receiving a lot of radio interference. We have a cell tower and about, 300 meters away, and we got lots of houses. And so I'm going to have to do what I can to try to improve that. In fact, I may just move this whole setup to my backyard where perhaps it's more radio quiet. So I'm fighting problems. Great dreams. Thanks.
Okay. Does look cool though, especially the barbed wire to keep people out of your installation there.
Yeah, that's right.
Yeah, everybody wants to go into your radio astronomy site. I'm sure that's the reason you got all the barbed wire there. Okay. Anything else for anybody? Did I miss anybody? All right. Thank you very much. And see you guys at Drake's Lounge in 2 weeks. Thanks, everybody.